Welcome to Getting Groovy. My name is Søren. Let me introduce myself. I have been a Java developer since the year 2K. I did get to do some migrations and handling issues with that. I worked for a small company in Odense called Gennemtænkt IT. Oh, by the way, I should ask but I know there's already one that speaks English, so I will keep this in English. Otherwise, I could have two. Excellent. I don't mind. Small company. We're only 4 people. We do consultancy in Groovy and Grails. I have been a Groovy and Grails developer since the year 2009. That was coincidentally also the year we started GreatConf. I'm very passionate about Groovy and Grails. I founded the conference called GreatConf. That's why I wear this very nice T-shirt. We just finished the conference at this very venue about 2 weeks ago. And I usually say I'm 100% nerd. My LinkedIn profile says nerd by nature as the heading. So call me a nerd and I don't mind. So the shameless plug, GreatConf. Check it out when the next conference is coming up. I can tell you that the next one is in the United States in less than, or just about a month from now. And then in India in January, and then we have the 10-year anniversary of GreatConf Europe in the end of May next year. And we look very much forward to that. No more plugging my conference. Now it's Getting Groovy. And the agenda is, where does Groovy come from? That bullet point there should be at the end, because that's actually what I'm going to talk about in the end. Why not just Java? Would somebody in this audience probably ask. And then I'm going to look a little bit about one of the compelling reasons, in my opinion, why we want to make Java more groovy. And look at some groovy code. And we're going to look a little bit of other tools in the box, and Grails, and Gradle, and Jep, Spock, Jeepers, and Griffin. And finally, I'm going to look a little bit on the Groovy and Grails adaption. So if you have any questions during this talk, which is going to be fairly fast-paced with 50 minutes on the clock and counting, please raise your hand and ask questions. I don't think I'll be around for the rest of the day if you have more questions. Okay, let's look at Groovy. If you look up on Wikipedia and look for Groovy, you will find this. It's cool, excellent, and amazing. And I think that pretty much describes the language as well. So, but let's look at the Groovy homepage instead. And they put a lot of text up there. Groovy is a powerful, optional, typed and dynamic language with static typing and static compilation capabilities. I'm going to stop here. And one of the things I like a lot about Groovy is that it integrates beautifully with the Java ecosystem. So anything you know from Java, you can pretty much adapt to Groovy. There are a few quirks here and there, but in general, Java code is Groovy code. So the history of Groovy, in short, it was started by a guy called James Stratham, and somebody has probably read the famous tweet that if he had discovered Scala, he would never have invented Groovy. And that is to some extent probably true, but he's a very active user of Groovy right now. So, and I actually expect him to come and speak on GreatConf next year. He has promised me to do so, so hope he will follow me up on that. So it was first mentioned in 2003, so it has well over, close to 14 years. He left, actually, Groovy quietly before it went 1.0. And it was picked up by a lot of developers, mainly a guy called Guillaume Laforge, who's still the project lead on Groovy. And they actually submitted JSR in 2004. Unfortunately, that was marked dormant in 2012. I don't think anybody actually had the time to follow up on that, so it's gone away. So in January 2007, they released 1.0, and then we have a continuous stream of releases. For a while, it was under the wings of SpringSource, and SpringSource was acquired by VMware, and VMware pivoted it out in Pivotal. So it was for many years under the SpringSource hat, and in March, or actually that was in January 14, no, December 14, Pivotal announced that they would retract their sponsorship of Groovy and Grails. So the last release was in March 15, and then shortly after that, Groovy became an Apache incubator project, and later that year, a top-level project, which from the Groovy core team was an indication that just because they lost sponsorship doesn't mean it's going away. On the contrary. So there's been a steady stream of minor releases. We're up to 2.11, and I just saw on the Groovy developer list that 2.4.12 is coming up in a couple of days. And they release at a steady pace. They have plans for the future. There's already a 2.5 release out. It has a new feature called AST macros, and I also know that it's dropping Java 6 support, which is not for most people a big issue. There's also an alpha release of 2.6. I believe, among other things, it's a new parser called the Parrot, based on Antler 4. And they also have in the pipeline a 3.0 alpha. One of the things they are trying to support is Jigsaw and a new grammar. And I know that Jigsaw is something that will cause breaking changes in Groovy, because there are some restraints from the Jigsaw. And they have mentioned a 4.0, which might feature a new meta object protocol, which is one of the backbones of Groovy. So why not just Java? Because Java is solid and Java is well known. The count I did was plus 10 million developers, if I looked that up on Wikipedia. And Java is by all means a fast language, but it's also quite verbose. It's sometimes a bit cumbersome, making getters and setters and what have you. And it's not dynamic, and a lot of people like that, and some people like the dynamic features of Groovy. So I'm not going to cover much for Java 8, but I am going to use it a little bit during this talk. So, differences from Java. Well, Groovy has operator overloading. So in Groovy, the plus sign is a call to the plus method. And an equals is actually calls to the equals method, not like in Java where equals is object references. So that's a difference. So we don't use equals when we compare objects. And so if we need to compare object references, we can use the is operator instead. So if one object is the other object, then it's the same object. There are no primary types. Everything is an object. So, and calculations is done in big decimal. Anybody have a clue why? Because 1 float plus 1.1 float is 2.1. A lot of zeros and then a lot of other decimals. Because floats and doubles do not have infinite precision. And big decimal solves that, and that's actually a very cool thing because it retrains the precision that we require. And since we have operator overloading, we can just write 1.1 plus 1.0 and get 1.2 as a result, 2.1 as a result, which is very nice. All methods and classes are public by default. All exceptions aren't checked, so we don't have to rethrow or catch everything. We can leave that up to a higher level in our hierarchy of call stack. And we have a dynamic type called def. And you can find more on the Groovy website. A little bit small, I cannot make it bigger, but this is a Java class. And we want to make this a little more groovy. So let's just start by renaming our class to Groovy. And it still compiles and it still runs. First thing we can do is we can, as I say, almost always, there are a very, very few things that do not run. The construction of arrays in variable definitions where you use curly brackets is one of the few places, but it's very easily replaced with a list in Groovy. So the first thing we can do is remove semicolons because they are optional in Groovy. We can remove the public keyword because everything is public by default. If we remove variables that are not declared private, protected, or public, they become what we call properties, which means that Groovy, compared to this one, we don't have to have a getter and a setter. That's synthesized in bytecode for us. So we moved the getter and setter. We have a very nice collection API. So instead of having this quite verbose prepare hello message where we concatenate the names, we can just call the join method, and that will replace, or it will put a comma between all the elements in the list. Huh? Yeah, the same Java now, in Java 8. Yeah. Okay, so yeah. That's why I say I haven't spent much time on Java 8, I have to admit, because I'm always working in Groovy and it works well for me, so I haven't spent much time on Java 8. But thank you. So another thing we have is interpolated strings called G-strings. So here, instead of using a plus, we can just use variable substitution inside the quotes, and we get a G-string. And we can actually drop the return value because returns are optional in Groovy. So Groovy will always return the last evaluated expression. We can use in our constructor here, before we had constructed the object and then we set values and then finally call the object, say hello. And now we just use what we call named arguments. So we put the name up here, or the values for the constructor up here. And one thing that happens is actually Groovy uses the default constructor, and then afterwards it calls set for each of the named arguments in the parenthesis. We can drop some of the parentheses. I don't recommend that, but that's also an option in Groovy. They are optional, but sometimes the compiler gets it wrong. And finally, it's actually possible to bring out the main part where we have the public static void main. We can extract that and has it as a separate script code. So what this means for that specific class is we have 28 lines of code in Java, and half of that in Groovy. So my claim is that you have less code to maintain. So one of the things I showed you was properties, and this is an example of properties in Java. And I know some people always say, well, the compiler or the IDE will create those getters and setters for us, and that's true. The thing is that sometimes that very important, if you create this and you have these getters and setters and one of them actually does something specific, we have this piece of code that actually is doing something specific to one of the setters. And if you implement that just where the IDE placed the code in the first place, you end up with code that might get lost. Yes?
Do you agree that if you have all the DTOs with getters and setters, you are not doing any object-oriented code, you are just doing
I agree on that, yes. But, yeah.
nothing on the extra to create such.
No, and I also usually when I do my talk, I recommend that if you are using Java, look at the Project Lombok, which actually allows you to do what Groovy does in this situation here.
It doesn't change the fact that you are still accessing the state of an object, whereas object-oriented programming lets you not do it.
Yeah, and somebody sometimes do it anyway. Yeah, that's true. I'm not disagreeing with you, but sometimes the value objects are not only value objects. Sometimes they have some kind of calculations in them. That's at least what I've seen from the projects that I've been working on. So in Groovy, it creates a value object in this case with the same setter, and everything else is synthesized in code. So if I use this from Java, I still have the getters and setters in the bytecode and can call it. Yes? Yeah, you'll normally do it by .setState. Yes, and Groovy. Yes, Groovy translates every. It attempts, because Groovy is dynamic, so it first attempts to call set and then in this case state, and if it has a method, it will do that. And actually, in bytecode, there will be a set state, regardless of you created it or not. If you created it, it will use the one that you created, and if you did not create it and just created the property, it will do the property. And if your variable was private, it will just use normal variable access. So and that's because it doesn't do it on compile time, it does it on runtime. So it actually interrogates the object and figure out which methods to use or which strategy to use. So as you can see here, we have various ways of getting and setting objects. The setters translate to, in this case, when I do Groovy person first name, it actually translates to set person first name. And down here, when I do the getter, it will translate it to get first name. So, and I can do the same on a Java object. So if I have a Java object, I don't have to call the getter and setter. I can just use the property access from Groovy. And same for named arguments. As I said before, it will first do the default constructor and then use the property access for the setters for each of the arguments. So in Java, when you have a method that can take one or more arguments, you would normally create a method first and then call the second method with the default value of the second argument. And in Groovy, you can define, first of all, you don't have to have a type. That's the optional type in Groovy. And secondly, you can assign a default value. And in code, there will be two methods. One that does call of the other one. I usually don't do methods without types, because I want to tell the next developer what my purpose of this method was. Unless I have a really good idea, and then my Java doc will probably state why I didn't put a type in. Another difference in from Java is that more things evaluate to false than just true or false. Actually, this entire list is a list of objects that return either true or false. Of course, false and not false is of course true. An object is true and null is false. A value, this is one of the things I don't like about Groovy, is that the value 0 is false. I hate that, but that was one of the choices that the developers that did Groovy to begin with did. The same with the value 0.0. Empty string is false, an empty list is also false, and an empty map is false. And some of those choices are good, and some of them are not so good. An object can implement as Boolean, and then it can decide if it wants to return true or false. So when you evaluate an object, it will evaluate to true or false by calling isBoolean. And then Groovy has some default implementations for that. So closures. Java 8 has lambdas, and closures is a little bit like it. And as I said, I haven't spent much time on Java 8 yet, so I cannot say what the difference are. So a closure is a method block that you can assign to a variable, and then you can call it or pass it around as an argument. So you can call it as it was a method like this, or you can call by using the call. But they yield the same result. And it can access the surrounding context. So in this case, it will return. It will look in the scope where it was created first to see if it will find a variable that is accessible. A closure can also take more than one argument. So in this case, it takes 3 arguments and just calculate the value of those. And inside a closure, it actually has an. If you don't define an argument like up here, it has an implicit defined value called variable called it that you can use. So that's actually every closure in Groovy has a value of the object with just one argument. And if you don't call it with an argument, that first argument will be null. So I just created a very tiny 2 Groovy classes here, a mother and a child, and something that can return the value from them. I want to go into the concept of safe reference. So in Java, if you want to safe reference something, you will check if mother is null, then you can get the value of mother. If it's not, And if you want to get the mother and child and want to get the value of child, you want to check if first mother is not null, and then later if child is not null. In Groovy, if you have mother is null, then if you do mother and then a question mark dot value, then you get safe reference, and it will return null if mother is null, and it will return the value if mother is not null. And the same for a deeper nested objects, you will get safe reference for mother-child. And the first time a null is returned, the expression returns null. And then in some cases that can be used because null is false, then you can use that in an if sentence to see if you will get something out of a deeper structure before starting to handle that. We also have an operator we call Elvis. So it does the same thing as this does in Groovy. So if I have a string and assign a value to it and then calculate a string value. So if the value is not null, it's the value, otherwise it's a default string. In case down here, I set the value to null, this evaluates to false, and then we get the default value. In Groovy, we will do it a little bit differently. We'll just use the Elvis operator, and if the first argument here returns anything but a false evaluation, it will return this value, otherwise it will return the default. So it's just a shorthand notation for the itinerant operator. We also have an operator we call the spaceship. Oh yeah, by the way, the reason it's called Elvis is it's a kind of a smiley that if you turn it around, it looks like an Elvis hair smiley. That's why it was called Elvis in the first place. So again, we have a Groovy object here, first name, last name, and then we create a collection of first name, last names. We want to sort this. So in Java, we could call sort by get last name compared to, and if it's not null, we can return that operator. Otherwise, we can return on the first name instead. So we sort by last name and then first name. Or we can use it with lambdas and do it like this. It can be even shorter. So in Groovy, we would do this instead. So the spaceship operator is actually a call to compare to. So in this case, we compare last name and first name, and then we use the Elvis operator, because if the compare to returns 0, the two objects or the two values are the same, and compare to will return 0 for strings, and then 0 means that we evaluate the left side, the right side of the Elvis operator. In this case, then we will compare the first names instead. And one of the things that we have in Java is a normal assertion. It will return this assertion error. So, and if we do the same in Groovy, and then I create a map, and it will actually show the values of the left side and the right side of the assert, so you can start comparing when you try to figure out what's wrong. So that's just, in my opinion, a cool feature. And it actually comes from the Spock testing framework. And it goes even further. It will show you where in the string the differences are. So collections. Let me just check my time here. 15 minutes. I'm way behind. So very quickly, strings in Java and strings in Groovy. So we define strings as just square brackets. And we have, this is arrays. We can also use size on arrays. And we can actually even go and get the last element and the last two elements from counting back from the list. So if we want the last element of a list, it's just -1. Lists looks very much the same in Groovy as arrays. We can do the same operators. The only difference is that if we access an element that does not exist on lists, we get a null, and in arrays we get index out of bound. And yeah, they look very much alike, right? Not much difference there, except that it's two different constructors or variables assignments. So it's very consistent. Maps looks pretty much the same here. We use put for Java, and in Groovy we use a constructor that looks like the list, but with colons between, and then the keys will automatically become string keys. If we put a parenthesis around it, it will evaluate the key to whatever type it is. And then finally, we can do ranges in Java 8. And in Groovy, we can do ranges just by saying 1.9. That will give us the numbers from 1 to 9 as a list. We can also do that for letters. So that's very, very, very quick subset of what you can do with collections. Some of the new features in is reading from files, and that's actually become a lot easier in Java 8. In Groovy, we can read the content of a file into a string just by saying new file, get the file name, and then write text. That will stream the entire content of the file into a string object. If we need to read a new URL, I don't know about the new I/O in Java 8, but for Java 7, that would pretty much be what you need to read a URL. In Groovy, you can do it almost the exact way as with a file. So that will open a URL connection, stream in the content to your string, and then close it again, and make sure that no open resources are left behind. This is just an example of doing operations on string. In this case, we go and capitalize Java. The first one is capitalizing. So, and in Groovy, we can call capitalize. So the Groovy string object has been enhanced by a lot of methods that is convenient. It will even let you call execute, so start a run process, run it against the shell, and close up again. You've probably all written XML in your test code, or to do a quick test of something and end up with something that looks like this. I know at least I did for a lot of years ago. In Groovy, they have enhanced the string type to allow multi-line strings by starting a line with 3 pings, and then it will actually do line character returns for each line as defined by the default settings for the JVM. It also has interpolated strings, like I showed previously, where you can insert the value of an object. And that will call toString on this object. And you can also do that with interpolated strings over multiple lines. So again, that's just a small subset of enhancements to the Java API, and the Groovy documentation is pretty good for that as well. So, parsing Java, parsing data, XML to begin with. I just took a Google API and it returned something like this. So what we could do is do it in Groovy and write a lot of code and do a lot of maintenance. And I'm sure there's libraries that can do this for us. In Groovy, it's pretty much built in. And I did write demo, but I have 10 minutes left, so I think I'll show you the end result instead. So first of all, we have something called an XML slurper. So that's made for streaming in XML and getting the content out. So what we have here is if we pass the URL, and of course we expect it to be well formed. If we want to parse an HTML page, we can use a parser called Neko, and it will actually allow us to read in not so well formed content. If we want to scrape something, there's probably other better ways of scraping things. Then we get our response, and if we look really quickly at the content returned here, we can see we have a status and we have a result, and the result has a type and formatted address and some address components repeated. And then it has some geometry and location. So that's what we want to try and get out. So if we want to get the formatted address out, we are looking at the result node, and then we look at the formatted address and call text on that, and we get the text out. We can also look at address components, and that could be addressed as an array or as a list of components because there were multiple of them. So in this case, we just write 0 and then do a short name and get the text, and we get the number 7, that's the address. And we can also do for that. So the general idea is we just write the attributes of the XML as variable references, and Groovy will, by introspecting the DOM, get the results out. What if we call this with something that does not exist? Well, if we call with something that does not exist, we just get an empty object that when we call text, we get an empty text. And if we try and dot our way down through a structure that doesn't exist, we'll just keep getting empty results. So there's no way to end up with null pointer exceptions in the Groovy XML slurper. We can also go and find the postal code in. So we search through the address components and find where the type has postal codes in them. And we can call to integer to get an integer out, and we can call to double to get the double out. So same thing for the API from Google again, just returns a JSON structure, and the JSON parser works a little bit the same. And in this case, we just use a JSON slurper, and in this case, the result is, it actually could return multiple results. And so we have to get the first result out. And then again, we can just dot our way. The only difference is that we don't have to call to text because it's the type of the JSON. So it will even be a string or an integer or a double or a Boolean. Those are the types, as far as I know, that's defined in JSON. So the same structure applies. We can dot our way down through the structure and get our results out. So writing data, writing XML. I have a small demo prepared, and with 5 minutes, 10 minutes, yeah. So let's just look at a little bit of code. So when you want to write Groovy, Groovy actually has a Groovy console, which is a small swing application from back then, but it still works very well for just doing demos. So the idea is that we can do what they call a streaming markup builder. So And then I just need to resolve that. Yeah. So this Groovy console is good for just testing small snippets of Groovy code. So now we have a markup builder, and then we can and now we start writing code. This could be, we could say this would be an XML or an HTML document that we want to have out as a small snippet. So HTML. So and then finally we just have to print line to string. So that actually creates some HTML for us, well formed, and behind the scenes it creates a DOM and create nodes and insert nodes into our tree. But this is a DSL in Groovy, and a DSL for writing specifically XML. If we want this to be well formed, we could do this, and we get it as well formed XML instead. It's still well formed, but pretty printed. So, and it could be that we want a range from 1 to 10, and then just iterate over that. It needs to be like this. And then we get XML out. So very simple example there. We just go to, where is it? The other way. Oops. Nee. There it is. So I had another small demo. JSON is pretty much the same way. It has a JSON builder where we can build JSON. I do, however, recommend to create a data structure and then just put that into the JSON builder as data, and then do to pretty print. So this is a map of data, and that will create some well-formed JSON for us that we can use. So Groovy has a lot of other things, which I don't have time to go through. It has a full meta programming capabilities, so we can actually go in and redefine methods on classes or on instances. And it has AST transformations where we can hook into the compile phase and add, for example, annotate our class with logging, and then it will put a logger in our classes. It has a lot of annotations for common patterns like immutables, canonical, hash code, and equals implementations, where it follows the principles of effective Java. It features domain-specific languages. As I showed a little bit, richer language and syntax sugar. It has some modules for, as I showed, XML and JSON. And JDBC, I have a very short example I'll show you at the very end. And has a template engine. So actually the template engine that Grails uses is from the Groovy itself. It features builders, and it's actually, if some people like to use it as a drop-in replacement for bash scripts, because you can use the shebang on your script and then make it runnable. So there's some other frameworks that I would like to mention. Grails, obviously, is a big thing, and it's a full-stack framework, and is in version 3.2 right now, and it's being actively developed. One of the things that happened recently is that the GORM implementation, which is the object relational mapper for Grails, has actually been extracted out of the Grails framework, so now it can be used standalone in your Java applications as well. So if you want some wrapper on Hibernate on various databases below, that's a very cool framework. It's been used heavily for Gradle, and I know that Gradle has switched to Kotlin, but that doesn't leave Groovy in the cold, first of all, because there's already a lot of scripts already out there. That doesn't go away so easily. And it's very easy to use for writing projects and getting started. So this is actually the project that I've been using for this code. Gradle is quite a lot more of a Bose and Maven, and this is just for a plain Java project. There's a framework called JEP, which is used for browser automation. So that's a wrapper on top of wrapper and DSL on top of Selenium. Makes it easy to either just use the driver, or you can actually write page objects and use that when you write tests, so you have a common entry point. And what it does is it overrides the $, so you can use jQuery syntax in your DSL code, so you can access objects in the DOM from your website. So very cool for testing, but also usable for screen scraping and other things. So Spock is a testing framework that's written in Groovy using heavily the AST transformations in Groovy, and so it can do things like data tables in your test code. So you can write your variables here, and then you read it like run the test for this row, and run your test for this row, and run your test for this row. And it will actually create a test report row for each of these rows in your test report. It also has a parallel framework called Jeepers that's built into Grails, into Groovy. That's probably been superseded a little bit by JX for Java. And if you're still into rich application frameworks, and there's a framework called Griffin, and Griffin uses heavily the GroovyFX and JavaFX libraries to do the front end, and it handles data binding and has a structure a little like a Grails application. So there's a lot of companies out there, big companies that uses Groovy and Grails. I have a kind of a fun case. I don't know, it's not known very much here in Europe, but I did this slideshow in the US. Omaha Mutual is a big reinsurance company in the US, and they actually started using Groovy before it went 1.0. And one of the reasons was actually that you could express, first of all, you could do Groovy scripts and execute small snippets of code. And secondly of all, calculations was done in big decimals, so they got out what they typed in. And that was actually one of the reasons, because their accountant people were the ones that were writing the scripts. And they needed something that would do the calculations right. Yeah, and I'm out of time. And also in Denmark, Erhvervsstyrelsen is using Groovy Grails heavily, and so is the tax board and the CPR board. So, very quick summary, and thank you.